Alright, last video for the week, we're going to look at solving quadratics with square roots, which normally should be pretty straightforward, except for the fact that many times this will involve complex numbers. Okay, now once a quadratic function is reduced to just a term squared, you can square root both sides. That way you isolate the variable. However, if there is a coefficient, obviously get rid of the coefficient first, then square root. Now it's easiest just to look at, just to do this by going over some examples. So for our first example, x squared equals 144. Well, again, I just simply square root both sides, just like we mentioned. That way, we get rid of the squared and the square root. That way, it just says x on the left side of our equation. Now, the square root of 144, remember, there's two versions, a positive and negative, so we'd say x equals plus or minus 12. So if it's asking you for two separate pieces, remember you need to mention that there's positive and negative 12 here. Okay, so pretty straightforward. However, if we get to x squared equals 72, well, get x alone by square rooting both sides. Now, this one, of course, will just become x, but square root of 72, we don't really know what the square root of 72 is. So we break it apart into two pieces. 72 is the same as 36 times 2. So x equals square root of 36 times the square root of 2. At this point I can say square root of 36 is 6 times the square root of 2. So 6 square roots of 2. But again, because it's a square root, we need to include the positive and negative version. So x squared equals 72 means that x is either positive or negative 6 square roots of 2. So that's how we can solve using square roots. Let's look at another example then. Again, these ones don't have coefficients in front. These ones all assume that a was 1. Take the square root of both sides. There is no such thing as the square root of 31, nor does it factor. So we just leave it as simply x equals positive or negative square root of 31. Pretty straightforward. Now we're going to get into a little bit more tricky things when we do have a coefficient. First thing to do in this case would not be to take the square root of both sides. Okay, instead of taking the square root of both sides, let's just get rid of this coefficient 4. Divide both sides by 4, and we'll get x squared equals 25. Now take the square root of both sides, x equals positive or negative 5. Okay, similarly over here, get rid of this 2, dividing it by both sides, x squared equals 32. Now at this point, take the square root of both sides. Square root of 32 breaks into square root of 16 times the square root of 2. At this point then we say square root of 16 is 4, so x equals plus or minus 4 square roots of 2. And our last one here, divide both sides by negative 3 and we'd get x squared equals 30. If we took the square root of both sides, square root of 30 doesn't break down into anything. We don't know the square root of 30, and it factors only into 5, 6, 2 and 15, 1 and 30. None of those things do we have a square root for, so we get it to this point and just say x equals positive or negative square root of 30. So this is how we'd solve using just real numbers, solving our quadratics by taking the square root. Next step, however, and again, all I did was x squared equals 144, negative 144. 72, negative 72. 31, negative 31. Down here, whoops, I suppose I should show down here first. 4 times x squared equals 100. Negative 4 times x squared equals 100. So these are basically the same exact problems, only there's going to be a negative involved. So that means there's a complex number involved. But you do the same exact process. Take the square root of both sides. So it looks something like this. Squared and square root cancel each other out. So we have the square root of negative 144, which splits into square root of 144 times the square root of negative 1. Remember, square root of 144, we found out over here, was positive and negative 12. Square root of negative 1 we just called I, so positive and negative 12i. How about for this one? We have x squared equals negative 72. Square root both sides, negative 72. When you take the square root, there's the negative portion, negative 1, and 72 breaks into 36 and 2. Square root of 36 is 6. We don't know the square root of 2, so that stays as a radical. And the square root of negative 1 is I. So it looks something like this. Positive and negative 6 right here. Square roots of 2 right here. I from right here. Notice this I is not underneath the square root. It's separate. X squared equals negative 31. Square root both sides. And again, that square root of negative 31 needs to split into 2. Square root of 31, square root of negative 1. We don't know a square root of 31, and we can't simplify it in any way, so it stays as positive and negative square root of 31. But the square root of negative 1 is I, so it becomes positive or negative square root of 31 times I. Notice I is not underneath the square root. Moving on to the ones that do have coefficients, divide both sides by this negative 4. So x squared equals negative 25. Square root both sides. So if you have the square root of negative 25, that's 25 and negative 1. Square root of 25 is 5, so it's plus or minus 5i. Moving on to this one, divide both sides by that 2. X squared equals negative 32. Square root both sides. Now again, the square root of negative 32 breaks into 3 separate pieces. Negative 1, 2, and 16. Square root of 16 is 4. Square root of 16 we don't know, or sorry, square root of 2 we don't know, and square root of negative 1 is I. So positive or negative 4 square roots of 2i. And lastly here, we'll divide both sides by negative 3, get x squared equals negative 30. Take the square root, and we get square root of 30 times square root of negative 1. I suppose I can top that off. And of course, this point, this will become I. This we can't simplify any. So positive and negative square root of 30 times I. Again, notice I is never underneath the square root. It's always a separate piece. And that'll do it for our final video. Again, because one of ours got pretty long, this was actually video 4. And all we did here was discuss solving with square roots, especially how it pertains to complex numbers.